All right, we're back in fisheye lens mode. We have a very sad M2 14-inch. This is an 820-02841-A. There are no schematics and board view files available for this exact machine, but the board is largely the same as the M1 Pro, which we do have a schematic for. So we're going to use that to solve most of our problems. And really, you know, the areas where we have problem, well, they're not much different than stuff we've already seen on a 14-inch. Liquid gets in on the edge of the board, and we have a big mess right there, and right there, and we got a mess here next to our CD3217. So, this largely, I haven't even bothered to run power through it. We see corrosion on the board. There's stuff that's obviously bad. I would prefer to not make it worse potentially. So, we're gonna clean off these areas. And realistically, what I'll do is I'll pull a CD3217 from another, I think I have an M2 Air donor. You do need to pull, you can't just use a new CD32 chip, like if you bought it from, Mobile Centrics or wherever. There's some weird pairing thing that's going on with, I believe it's with T2 inside of the Apple silicone or something, but we need to pull this chip from basically another Apple silicone board, reball it, then put it on here. We can't just buy a new chip and put it on there, which is annoying, but not, whatever. We'll reball the chip basically, and then most of this stuff back here, I'm basically just going to find analogous replacement parts from another board. We already took this out of the chassis. The chassis itself looked okay. There's a little bit of superficial corrosion on like a speaker and a fan that can be cleaned off. No big deal. This cannot just be cleaned off though. We must replace these components because they are quite sad. So. We'll go over to microscope vision after I grab my donor board, and then we'll start fixing MacBook. Ouch. Ouch. Yeah, I think we'll just maybe clean up this area. I probably want to touch up the connections on these resistors. Just like to get a quick once over of our corrosion before we clean it, so I can reference this later. I'm assuming this is probably our main problem. I would bet one of these bad boys is shorting. Let's see what those lines are. Let's see. I will say this area on my board view is quite different. Let's see what I'm looking at. Pretty different, pretty sparse on this 14-inch board view file. A lot of this stuff is quite similar. This whole area up here, same stuff. Basically same stuff. We have a lot of different things. Okay, well, let's clean it up. We don't have an exact schematic, so we'll use our heads. Clean you up, MacBook. Gosh, I think after cleaning this, it kind of doesn't look terrible. What does this do? You want to power supply. I have a USB-C plug in this now. I'm going to run power through it. See what it does. Stuck at 5 volts. We're going up to 20. Is this godforsaken machine turning on now? Well, it's not turning on. I tried to turn on. Saw this guy draw some juice for a moment and start up. What's up? Hello. Okay, So we reballed our CD3217. We kind of just reflowed the solder in these other areas with heating this. This area back here, we had no measured shorts. I also don't have a board viewer schematic. I'm not sure the exact values of these parts, and they're working right now, and really they're like a little bit charred at the end. They'll be fine. I think what I want to do at this point is basically just ultrasonically clean the board and put it back in the chassis, because it kind of seems like it's turning on. I'm not sure how this exact board behaves when it doesn't have everything else plugged in, but it does get 20 volts now, and we get some current draw. So if we plug in a USB-C port to the board, I'm seeing a little bit of other corrosion right here too, just on some test points. That's pretty superficial. We'll clean that off with a Q-tip. It'll be fine. Okay. But now, it seems like the MacBook is turning on. Plug in power, we got our 5 volts initial. Climbs up, 20, getting 0.2 amps. I feel like this might just be turning on now. So I'm gonna basically ultrasonic the board where we were on the side where we did the rework and where the bulk of the corrosion was. And then we'll reassemble it in the chassis and stress test it if it is working, or we'll see, it's crashing on startup or whatever, who knows. We'll get that on there and test her out, basically. And we'll be back when we do that. I'm probably going to ultrasonic this tomorrow because I'm tired and I'm going to go home. The ultrasonic cleaner takes like an hour and a half to heat up, so we'll do that then. And then we'll see what happens. All right, we ultrasonically cleaned the board. I actually had to go get more distilled water for the ultrasonic cleaner. But the board looks much better now. We reballed the CD3217 on the top side here. Pretty much what we saw on this, it would just cycle. It would go up to 20 volts and cycle back down to 5. That's pretty much it. And, nothing else really around here worried me too much, but this is kind of a problem that's not exactly specific to this machine. So I feel like if you pretty much ever see corrosion around these USB-C controllers, you should just reball them. They're sensitive. If it was maybe stuck fully at 5, I'd probably just want to replace it, but I wanted to try just a reball first. And that does seem like it's working now. And then the ultrasonic cleaning is just to get, any other corrosion off the section. Really, for this case, we kind of just needed to do, essentially from here down. So I just kind of dunked this in the ultrasonic. We didn't need to fully submerge the board because we really didn't have corrosion anywhere else on the device. But now, when we plug in the board, let me open up my USB software. And I have a USB port plugged into the MacBook board. So what we'd basically see before is it would get to 20, then it would cycle back down to 5 and just kind of keep doing that. We see it stay at 20 now. I think it's going to turn on, so we're going to reassemble it and test it, but I think this will probably work now. I suppose we'll find out. But yeah, we'll put this back together and then we'll be right back. I reckon. So we got this back in the chassis, and now what it would do would just stay at 5 volts. I would get 12.3 volts on PP bus. Actually, I found what part in the chassis is causing this behavior too. Okay, so the actual problem on the board was we're cycling 5 up to 20 down to 5. We reballed a USB controller. Board worked outside of the chassis. I reassembled it, stuck at 5 volts. That's different. So I plug in power, and we would just get this sort of behavior: 5 volts, low current. We got 12.3 on a PP bus, which we can measure on these fuses up here. I'm gonna unplug power now, and basically what I did, actually just kind of parsed through it. I unplugged things one by one. I thought, maybe, battery. No, it's not the battery. It's not the trackpad. It's not the keyboard. It's not these other sensors. I thought, the corrosion actually was kind of over in this area over here. I thought maybe the fan could cause it on this. I was maybe a little bit far-fetched, but, you know, I was just trying stuff. And what we found was that it's the dang nabbit. It's the angle sensor, and if we put it at an angle, we can see there's a little tiny bit of corrosion on there. So this is actually causing it to not turn on. So I will use a little programmy thingy to program a new sensor, because I actually happen to have one, because I had an M3 14-inch that has the same part, so I think I have an extra one of these, and I have that programmer, and we'll swap that out. Oh, but basically, yeah, right when this is unplugged, and then we plug in power. Let me show you, if you don't believe me. We see the amperage climb up, 20 volts, it'll turn on now, basically. So I guess angle sensor was causing this to not turn on. I actually wonder, these just always seem to get corrosion right on this part. Now it would seem. What do we actually have over here? So what it's probably doing is it's shorting out 3v3 AON. In fact, here, let's we can plug this back in really quick, and we'll just measure in resistance mode on this line. I would assume it's shorting 3v3 AON, or maybe 1v8. Can we measure this easily on the top side of the board? Oh, not really. It's only on the back side. What about V8? Okay, also on the back side. Or yeah, we could measure right here on this. Let's see if perchance it's shorting out this 1v8 line or something like that. We're stuck at 5 volt though, so I would assume it's that basically this angle sensor is just shorting out 3v3. Yeah, no short on there. So we can assume it's causing a short circuit on this line, basically, because we're getting this stuck at 5 volts behavior when it's plugged in. Yeah, no, we're on the top side to measure. That's sad. But, you know, something back there, right? We're going to replace the sensor. We know it's bad. It's causing it to not turn on when it's plugged in. So we're going to replace that too. Pretty much. And we'll be right back. It's angle sensor madness on the 14-inch MacBooks. The last M3 I had also had a bad sensor. I think that this is probably going to end up being very common for liquid damage 14-inch machines. Liquid seems to get in right there and get on that sensor. I'm sure it will get in on the other hinge too. It's just there's no little calibrated sensor thing on there. Do you have just a pentalobe screwdriver? Thank you kindly. Okay. All right, so we're gonna unplug bad sensor. Remove it. There's a single pentalobe screw on there. And it gets magnetized to the MagSafe thing. And grab it with a pair of tweezers. Okay. We're going to take our new sensor. We're gonna put it on. Fold this first. Let me switch to the microscope cam. All right, here's what we're doing. Screw the thingy in. Then, let me say, I will say, I'm actually, I don't know if my calibrator tool's bad. I actually did not need this thing until like 5 days ago. On the M3 machine, this just didn't work. I don't know why. I think we just do this, plug in power, And then I think it was switch to... I'm actually going to probably look up the instructions again on this. Okay. Set up in 4 easy steps. Follow these steps. Close the lid of your MacBook and unplug the battery and the power supply. Check. Socket J3 for MacBook Pro. Check. Connect a 5-volt power supply to your nerd tool. Check. LED open shows calibrating the sensor. Press switch 1 for MacBook Pro. Okay. And then it says this light is going to blink for a second. And then what I should see is that the lid open light goes off. It is no longer on. Okay, so it worked on this. So for some reason it doesn't work in the M3. I don't know why. The part's exactly the same. And then what we should see now is if I open this like about 15-ish degrees, lid open, I close it, lid closed. Okay, cool. So it works. Very fun. On the M3, what we did, because this thing just wouldn't work with it for some reason, not sure why, is I just desoldered the chip from the original sensor and I put it on the new one. And that worked. This guy, honestly, I would reckon actually on this, because that other sensor just didn't really behave. This one was, you know, shorting out the machine and causing it to not turn on. I would reckon transferring the chip on this would not work. This chip is almost certainly going to be dead on this guy. So good thing the calibrator tool works. We'll finish up. We're going to kind of close this up now and test it. Make sure everything else is behaving. All right, we need to activate fancy mode. So the device is still doing this cycling behavior. It seems to be doing with everything unplugged too. So I think there's something that's still a problem. I see the current go to like 5 volts, 0.3 amps, and then it drops to like nothing and then go up. I have this little tool here. So this is the same thing I'm using that makes the, you know, that I use as like a window capture in OBS to show, you know, what's going on. I wanted to, we're gonna do this, create new, and I'm gonna click start. And we'll see what happens here. It's masquerading as a happy MacBook. This is all pretty normal. I see our voltage climb up, cool. 0.3 amps, we're trying to turn on, 5 watts. And then it hovers around 0.22 for a while. We'll see it drop to nothing. And we see this kind of spike right here, and then we're getting 20 volts really, really low current, like nothing. I'm gonna pause it now, and we can see, I think our PP bus is at like 12 volts, something like that. Oh, let me open up our other fancy software. Okay. Let's see what we get on our PP bus. 12. Low. Something, I think, in a later stage shorts and then makes it do this, is what our little graph tells us. So I'm going to take the board out again, and we're going to look at it further, and we'll use our brains rather than just reballing a chip that's corroded. That being said, with the CD32, if it is corroded, reball it. Or replace it. They're sensitive. If it's not, you know, they generally don't really live long with corrosion if they're not reballed and they're still working. If they are dead, you know, replace them basically. But there's something else going on here, and I imagine it is in that area on the board where we have quite a different layout. Basically, we can actually just kind of look on the top side here. Let me open up the Pro board. M1 Pro or Max. I mean, it's, the difference is just around here, which doesn't really matter for our purposes. But right now we're looking at, like, let's say, this area. There's no CD3217 on the top side of the board for the M1 machine. We don't have a schematic fully for the M2. Some of the areas are quite similar, but this area is pretty different on both the top and bottom side. We have a fairly different layout on the actual physical board here, so we're gonna have to maybe use some context clues. What I'm thinking we'll do is we'll run USB power and we'll look at this under a thermal camera in this area, and I think we'll possibly see what part is misbehaving. So we're gonna take the board out again and then we'll be back. All right, reverse spoiler alert. Didn't see anything on the thermal camera. So we are looking at the board a little bit more closely. And really, our board view is basically irrelevant for what I'm looking at right here. It has different stuff. I don't think it's really even close to similar what's going on over here. On the M1, we basically had our CD32 over here. We got some other stuff. I know it's for like HDMI, but we have this stuff near SD card reader right here. And it's almost like we have all these surface mount components and we have some extra circuitry over here on the actual board. I kind of just closely inspected this area on the back side with corrosion, and I think I've maybe found a problem. Probably these capacitors don't really look too happy. And I think this resistor right here is an open line. That pad doesn't really look too happy at all. Let me actually see what we get in a diode mode measurement. We'll switch over to the diode mode. Not open, but yeah, that doesn't look too happy. I really think that probably not incredibly low, but these might be shorting like actively, so when the device has power, they're not happy. That's like 1,000 kilo ohms. I think in any case I don't like the look of those caps. Check a few other things here. Very well might have reballed that CD32 for no reason. This area didn't have any liquid. It was basically just this area and near the CD32 had corrosion. Let's see what the... Okay, so this is like an 100K resistor. I have those. We'll just replace it. Let's take this off. I think I'm going to replace just this first and see what happens. I still have the cycling behavior.
Go from the top side and let it fall down.
Sorry? Okay. I kind of think this guy doesn't look too great either. Let's see if we get a good measurement on this. I know this vertical one's 100K. 90K. I think I'll just touch up the solder. pad is gone. Right, this very well might have been our problem, and that kind of makes more sense. We didn't see any thermal signaling. You know, circuit's gonna fail, it's gonna be open or short. Oh yeah. Alright, since we weren't seeing anything get hot, it's likely we had an open line somewhere. Or, you know, I don't know, it seemed like some later stage rail. And generally if you had that, you would see something getting hot, just running power through USB-C. We can see these pads are just totally gone. Really what we're doing is we're just kind of scraping off the oxidation on these pins so we can get a good solder joint. Don't want those bridging. Okay, I'm gonna go grab a couple resistors. I'm gonna go low airflow, 430, 60 airflow. First, just kind of. Get off of there. Okay. Do we know what spec these caps are? Not really. I want to see if we see a difference with these resistors replaced first, and then if we still see nothing, I think I'm going to remove both of these capacitors, so I don't trust them. Don't trust them. I'm looking around for any other resistor points that look sussy. This guy maybe. looks a little bit sussy. So we'll just reflow it. That filler's on there. Okay. Anything else, perhaps? Perchance. I might as well inspect this while the board is cooling down. Just see if we see anything else that looks like a problem. Not really. Okay. Okay, let's see what MacBook does now. That's why it thinks that my will a MacBook work now? We are seeing if the current drops down. Still does it. And then we get nothing. Let's see what we're getting on these capacitors. I did not believe in magic until I saw my dog turn into a snake. I have been trolled for the last 2 hours by my own USB tester. This is what we use to have the USB current basically show up on the computer easily. At some point during fixing this thing stopped behaving, I guess. It works now. It's running 20 volts, 4.2 amps, battery's charging. We're okay. This probably was working after I initially reballed the A2779. I don't know why this stopped working suddenly. I basically had the board on my bench and it looked like it was on. I put it back together and I saw this weird cycling behavior. Well, I guess initially I saw when I plugged in the lid angle sensor, it was just stuck at 5 volts basically. So we saw that was a problem. Okay, we replaced the lid angle sensor. Then we see this weird cycling behavior, which I didn't see before. Weird. Took it all apart again, probably looked at it for another 2 hours. Really, the only other problem we actually found were those resistors with the open line, so I suppose it's good that we found that. But this was causing our weird drop down to 5 volts, go back up to 20, low current behavior for whatever reason. So this betrayed me. I'm using Old Reliable right now, which doesn't plug into the computer. It's, you know, lower tech, but it works. It's just a USB-C, you know, PD listener. So, you know, be mindful of your USB testers. I think I've gone through like 3 or 4 different versions from different people with these softwares. They all seem to work for like, you know, a few weeks and then they start bugging out for whatever reason. Frankly, I think it might be the Windows install on my Office machine. So actually, I probably am gonna begrudgingly just clean install like Windows 11 on my computer because it is randomly misbehaving and OBS crashes or whatever. But MacBook works. We reballed the CD3217. We replaced the lid angle sensor, and then we fixed a few open lines on some resistors and ultrasonically cleaned the board for the section that was corroded. Basically, inside of the actual chassis, really the only corrosion we saw was a little bit on a USB port, which we cleaned, and it works fine. That's actually where we're plugged in right now. It's working okay. And then there was also some sort of superficial corrosion on like the fan casing, which doesn't really matter. It wasn't on electronics. We still cleaned it off though. We don't want corrosion just sitting inside the device. So we'll catch you in the next MacBook video. And you know what, actually, luckily, the reason I actually kind of figured out there was something wrong with my tester was after looking at this for 2 hours and not really finding anything wrong, I went, you know, screw it, I'm kind of getting frustrated with this, I'll look at it another day. And I had a mailed in another A2779 M2 MacBook Pro in here for an LCD replacement, and I put that on my table. And I saw similar behavior. It would go up to 20 and then cycle down to 5 and then go to 20 with low current. I'm like, what the hell? Actually, I don't know, maybe this guy also has liquid damage. It's not actually a bad LCD. He has a device that's not starting up. So I called the customer. I talked to him, and he said, well, actually, it would turn on. I could use it on an external display. You know, I went, so I kind of took that at face value and thought maybe there's something wrong with my cable or my power brick or something. So first thing I did was actually just unplug the tester because I have had them cause problems before, and then immediately, yeah, that guy's computer turned on and very much did just have a broken LCD with lines through it. But with this tester, the thing will not start up. It doesn't like this for whatever reason, so I'm returning this. And I'm probably going to go back to using the other one that I had. The software on that didn't work that well, but you know, I could make it work. All right, I'm yapping too much. We'll see you in the next MacBook or whatever thing ends up on my table repair video next time. Have a splendid day and a happy Memorial Day. This is probably going to be uploaded far after Memorial Day, but in any case, merry whatever's going on.